This is Chapter 6, Part 2. We are going to talk about sound wave. Sound wave is a longitudinal wave. That means the generation of the wave is in the same direction as the propagation of the wave. In this case, if we keep making the disturbance this way, the sound is going to travel to the right side. That's called longitudinal. There are two very important features of the sound wave. One is called frequency. The other one is called amplitude. Frequency, once again, it will have the unit of hertz. That means how many waves per second. Okay, unit hertz is per second. Okay, something per second. Okay, sometimes you write it this way, s to the minus 1. Okay, so let me give you an example of what different frequency is. That means you can have different pitch. Okay. What you heard is different pitch. Okay, so that means you have different frequency. The other one is amplitude. Amplitude is not about the pitch. It's about how loud the sound is. For example, ooh, ooh. So the second one is louder. Okay, if you have a louder sound, then you have a higher amplitude. Okay, the unit for this one is dB, is decibel. For our human being, the comfortable zone will be anywhere between 3 to 60 decibel. Okay. Usually our conversation is around 40 to 50 decibel. That's usually how loud we talk. Okay. Over here, for frequency, the audible frequency will be anywhere between 0 to 20,000 hertz or 20 kilohertz. Beyond that frequency is not audible. That means we cannot hear the sound. Even if you make it very loud, we still cannot hear it. So we cannot hear it. Maybe other creatures can hear it. For example, maybe the bugs can hear it, maybe the insects can hear it, or maybe the mouse can hear it. For example, I'm just making up a number. Let's say the mouse can hear the frequency of 30 kilohertz. Okay, and we cannot hear that frequency. So I'm going to make a device that generates that sound at 3000 kilohertz. So the mouse can hear a very loud sound and will go away. But as a human being, we cannot hear that sound and we hear nothing. So we can use that principle and create a mouse repellent. Just make a device, plug it into the wall, generate that frequency of sound, make it very loud, repel the mouse, but we do not hear it. Any frequency above 20 kilohertz is called ultrasound. Okay, so don't be confused with supersonic. Okay, supersonic means when you have a wave that the speed is faster than that of the sound, is called supersonic. Ultrasound means just the frequency is above the audible frequency, that is 20 kilohertz. Okay, so let's talk about sound wave in other applications. I'm going to talk about something is called the Doppler effect. Okay, so we can have ultrasound, we can have that to measure the speed of a moving object. Okay, there are different ways of application of the Doppler effect. Okay, for the car, sometimes when you drive and they hide somewhere and try to measure, see if you are speeding. The device that they used is called a Doppler device, or it has a Doppler effect. How does it work? So he has a device over here. Let's say this is a detector and also a sound generator. For example, if it makes something, let's say, have something, for example, I'm going to make it, let's say, the same thing, 30 kilohertz. Okay, so this is a sound generator. It's going to send out an ultrasonic signal. When a car is moving, if it moves at certain velocity and touch this sound, it's going to change the frequency. Okay, so when it change the frequency, and it's going to return back to this one. So with the same device, you can generate a wave, and you can also make a detector here, can detect a wave. For example, now is 30,025, let's say. Okay, now you gain 25. Before you have 30, exactly generate this, but now it's changed. So by the difference of these two, we can calibrate it and we can tell how fast this vehicle is moving. This is called the Doppler effect. The Doppler effect, there are two different effects. One is the object is moving, but the source is not moving, just the object is moving. That's one scenario. The second scenario is the source is moving, the detector is not moving, the object is moving. Okay, and the third one is both the source, well, in this case, the source is not moving, just the car is moving. Okay, so there are different ways of having the Doppler effect. So for example, the source is moving. Okay, secondly, the object is moving. Okay, at least two examples here. Okay, and by the way, when you drive, please try not to speed.